Hey everyone, welcome back to the channel. This is Vahid from VRF Education, where we make learning programming simple and practical. In today's video, we are diving into one of Python's most powerful and elegant features, decorators. Whether you are just starting out with Python or looking to sharpen your skills, decorators are something every Python developer should understand. So let's jump right in. Decorators in Python are a powerful feature that allow us to modify the behavior of a function or a class without changing their actual code. They work by wrapping another function, which lets us extend or customize its behavior in a clean and reusable way. So what does it mean? Why do we need to extend or even customize the functionality of a function or the operation inside a function? Well, based on single responsibility principle, every single method inside your code should focus on one task. And that task is somehow related to the core business of the application. For example, we want to register a student. And in some points, we want to add other functionalities to this method. For example, logging, caching, access control, or timing function. These are not related to core business of our application, but we need to somehow handle them. These are out of the scope of those methods. So these are cross-cutting concerns, and we need them somehow to take control over the codes or improve the performance of our codes. Decorators is one of the best choices to handle cross-cutting concerns in your code. We wrap a function or a method that contains the core business and add those functionalities that we need, for example, logging or caching into that specific method. Decorator pattern is a common and widely used design pattern in software development, not just in Python, in many programming languages out there. And we're not going to focus on this pattern in this video. We're going to focus on decorator feature, a feature of Python that let us modify or customize the current codes without touching them or changing them. And this is a sample of decorating a function in Python. Here we have a function named myFunction, and we decorate it with myDecorator. My_decorator is another function that wraps this function easily. So this is also another function. We're going to talk about it, how to implement it. All the decorators in Python started with @ at the beginning. So this is the way that we're going to decorate a function in Python. Before we dive deeper into decorators, it's important to understand that in Python, functions are first-class objects. This means that functions are treated just like any other object. You can store them in variables, pass them as arguments to other functions, return them from functions, and even store them in data structures like lists or dictionaries. This flexibility is what makes decorators possible, because we can pass and return functions just like data. So after slides, before we get into decorators, first we check all these items related to functions in practice. And after that, we get a good sight on what functions are and how we can treat with them as objects. Then we continue on decorators. And these are some common decorators that you might have seen in Python codes. And these are mainly used in object-oriented programming. But today, we're going to see how we can use decorators with just normal functions, not method inside a class. So let's go to VS Code and start our journey. So let's start with a reference to function or saving function inside a variable. First of all, I'm going to create a function named shout. This function will help me to make a text more emphasized. For example, it receives a text and I'm going to return it with uppercase format. So it's somehow emphasized, or I'm going to shouting out. Now, if I want to call it, you can call it this way, print shout, for example, Python. I'm going to pass Python text here. This is obvious, so let's run it. You can see Python returned in uppercase. Here I'm going to save it inside a variable named sample equal to shout. Do not use parentheses. I'm not going to call the function. I just want to assign it to another variable. So from here, I can use sample just like shout. This is an alias or a reference to shout. So I'm going to say call sample as a function with the input of Python. If I run it once more, you can see we have the same result here. And also we can pass this function as an argument to another function. What does it mean? I'm going to create another function named whisper. Whisper. Again, it received a text, and this time I'm going to return it as lowercase text dot lower. This is it, and I don't need this one and this one. So I'm gonna create another function named greet. This greeting, based on my mood, want to use shout or whisper method to print a welcome message to users. For example, I'm gonna shout on user or whisper something to the user. So here it will receive a function, a reference to another function, and let's print it here. Not gonna return it. Print that function, and I'm gonna say, hey, welcome to my app. This is my message, and I'm not gonna format it here inside the greet function. I said, please send me another function. I will pass the text to that function. That function is responsible for formatting this greeting message. So I'm going to call it something like this, greet, and pass shout to that function. Again, do not use the parentheses. We're not going to call shout. Just pass the reference to that function to the greet function. So if I run it, you can see here, hello, welcome to my app is printed all in uppercase. And if I change it, for example, to whisper, this time I pass the whisper function as a parameter to greet. So let's run it. You can see all the text converted to lowercase. So this is the way that we can pass a function to another function. Another thing related to function is that we can return a function from another function. What does it mean? Let's comment all these codes and also clear the output. Imagine that I want to create an adder function, something like this, def adder. It received two input parameters, x and y. So I'm going to return x plus y. It's obvious and it's nothing tricky here. So I'm going to call print adder 10 and 2. I'm going to duplicate a couple of times, 10, 12, 10, 22. So if I run it, the output is obvious. You can see we have a duplicate here. Imagine that most of the time our first argument is fixed. We want to add something to 10, add something to 12, or something like this. I'm going to change this function to something like this. I'm going to create another inner function here. The name is adder, and this time it receives only one argument, the second argument, the y. And inside it, I'm going to return x plus y. So it's the beauty of this function. And for the upper function or the wrapper function, the adder, I'm going to, so this call it to create adder. This is a create function, create adder. And I'm going to return adder. Again, not calling the function, just return the reference. So when I call the create adder, I pass two arguments, x and y. X play as constant here all the time after we create the adder function, and we return the adder. So how can we make use of this function? I'm going to say add underline 15, for example, equal to create adder 15 as the first parameter, and just 15. And here we don't need to have this second parameter. It should be dynamic. I forgot about it. So adder 15. And from now on, I can call add 15 instead of adder, or add 10. Let's change it to add 10. And instead of calling adder with two parameters, I'm going to call add underline 10 and just remove the first parameter. Here we need to just pass the second or dynamic one. If I run the application, again, we have not the same result because I passed 15 here. We should change it to 10 and run it once more. So exactly the same result as we have before. And also we can create another adder. For example, add underline 20. It's very simple. Create adder, and this time I pass 20 as the x parameter, and y will be provided later. So I'm going to duplicate this one. And here, instead of calling 10, I'm going to call 20. So let's run it once more. Here we have 22, 32, and 42. So this is the function reference to this inner function, the adder function. This is the way that we can return a function from another function. We will use it very soon. Now let's create our first decorator. It's very simple, and we want to see how decorators works. We are not going to use decorator feature in Python. First of all, I'm going to create a function. For example, function underline to be used. I'm going to use this function. It does not have any input parameter. I'm going to just print. This is a message from decorated function. And let's create a decorator. For example, I want to create another function named def hello underline decorator. Oh. This function will accept another function as its input parameter. Now I'm gonna create another inner function inside hello decorator. I'm gonna call it inner function. This is my inner function, and I'm gonna return it just like what we did before. Return inner. And inside inner, I can extend the functionality. For example, imagine that I want to take a log when I entered and exit from another function, in the created function. So I'm going to say print before decorated function, and I'm going to duplicate it, print, or after decorated function. And between these two print statements, I'm going to call the function that passed to our decorator. So this is the function. This time we use parentheses to call it. So when we return the inner function, whenever we call the decorator, we have another function that wrap around this function, and we can take log here, or for example, check the authentication, or calculate the execution time of the function, or things like that. So let's see how we can use it. Without using a decorator feature, if I want to use this function, I need to handle it in a very weird way. First of all, let's call this function to be used. I'm calling it. Oops, no semicolon. Clean this one. And after that, let's print a separator. And then I'm gonna decorate, use the hello decorator, and pass the function to be used to that decorator. And I'm going to save it again to function to be used. So it acts as another wrapper function. I change the reference. I pass it to hello decorator and save the reference inside function to be used again. So I'm not going to create an extra parameter. So let's call it, for example, helper function. Oops, helper function before the function, and here I'm gonna call helper function and also function to be used after that. Let's see the result. Here you can see this is a message from the created function. When I call the helper function, first I printed before the created function here the main function that we passed as a parameter here, and also after the created function, and then again we have function to be used. It acts simply, but I want to take log whenever I call this function. So instead of saving the result of the hello decorator inside another reference, I save it inside the function itself. So if I run the application, oops, what's happened? Function. Oh, I forgot to call it. And this time, when I call the main function, the function to be used, you can see we run the decorated function because we saved the reference inside this variable or inside this function name. Let's have another example about calculation execution time of a function. I'm gonna create a factorial function named factor. Let's also comment these functions here. Factorial function, and I'm gonna print using math. Let's import it. Import math and also import time. Math dot factorial of 10. I'm not going to pass input parameter right now. And then here I'm going to say time dot sleep for 2 seconds. We need to sleep the threads for 2 seconds, and after that calculate the factorial. So how can I compute the execution time of this function? I'm going to create another function named calc underline time. It receive another function because it's gonna calculate a function execution time. So I'm gonna create the inner function here. And let's just use pass here and return the inner function. So here, first I'm gonna use a variable to save begin equal to time dot time. Save the output of time method inside the begin. Call the function that we passed to the calc time decorator or calc time function. It's a function. And then I'm going to use end equal to time dot time and print total time taken in comma func dot dunder name, pass the function name, and then end minus begin. Sorry. So using this function, we can easily calculate the execution time of another function. So how to use it? Again, just like before, I'm going to say factorial, it's equal to calc time of factorial, and then call the factorial function again. So this is the decorated one. We reassign the factorial with new inner function here. Let's run the code. And you can see after 2 seconds, we have this output, and also total time experience in factorial method is 2 seconds and a couple of milliseconds here. But it's a little bit hard to do this. For example, pass the function to another function and save the instance inside the original function and call it. It's tedious, and it's not make sense to do this on every function that we need to calculate time or take log or other cross-cutting concerns. So we can easily comment this line. And in Python, whenever you want to decorate a function, as I told you at the beginning of the session, just use @ and write the name of the decorator method. This time it's calc time. So with this notation, the factorial will pass to the calc time, and the inner function that we declared here, and we'll return it, save inside the factorial. So if I run the code, you can see the output is the same. Now factorial is decorated function. We don't need to use this line anymore. So this is the beauty of Python. You can decorate any method with another method that accepts a function as the input parameter. This is the simplest way that we can decorate a function in Python. The next thing that we need to take care of with decorators is how we can pass parameters to our original function. Here we have this 10 as a constant here, but I'm gonna receive it from the input. So I have a number as a parameter to the factorial real function, and here again we have we pass the number to the math.factorial function. So I'm gonna pass 5 here. Whenever you have some input parameters to your function, you need to add args and kw args to your inner function. So I'm gonna pass args and kw or keyboard arguments args here, and pass them also to the function to be called inside the inner function. So if I save this code and run it, this time we need to see the factorial of 5 is 120. So it's correct. And you can change it, for example, to 8. This time the parameter 8 passed, the value of 8 passed as a parameter, and this is the factorial of 8. And this is the decorated operation that we supplied for this calculate or calc time. Next item after handling the arguments is handling the return value from a function. Imagine here, instead of printing the output of factorial, I'm going to return it from the factorial function. Return, and here I'm going to save it inside variable name result and print the result. So in these scenarios, you need to save the return underline value inside the inner function and return it. Return value. This is very easy. So if I run the code, and let's also change it to 1 second. After 1 second, you can see this time we have the result after the decorated message, because we printed after calling the factorial, and during the calling the factorial we print this print expression here. We have it here before printing the final result. So this is the way that we handle the output of our decorated function. We get it here inside the inner function and return it. We can also work it just like a normal function inside our main codes. So now you might ask that with this notation, can I have multiple decorators over a function, or we can just use one decorator for each function? And we need to apply all the things or all the modifications that I want to apply to a function to just one decorator. So based on single responsibility again, we need to also make decorators, these are also functions, focus on one task, one single responsibility. So we can apply more than one decorator to a function in Python. It's not a big deal. So I'm gonna comment this function. Another sample. Let's see, what should I do? Well, for this scenario, imagine that I want to create two new decorators, power decorator and doubler decorator. These are somehow mathematical decorators. These are imaginary, not for real scenarios. But power decorator will call a function that return a number and multiply the result by itself. And doubler will multiply the result by 2. So here we have what? I'm going to create power underline decorator. I'm going to use dec. And this will receive a function. Inside the inner function, def inner, I'm gonna save the result of the function inside a parameter named x. We don't have an input parameter right now. And after that, I'm gonna say return x multiplied by x, or power x by 2. It's the same. And here I'm gonna return the inner function. And let's duplicate it and change it to doubler. Doubler decorator, we get the result of the function and multiply x by 2 and return the inner. And I'm going to create a function named gets number. I'm going to return 10 explicitly here as a constant. And then I'm going to print num, calling the function num, and decorate it with those two decorators. Get number, not num. Get number. I'm going to use @power decorator, and then after that @doubler decorator. So it's like we call it in this way, power decorator, and pass doubler decorator, and then pass get number function to this doubler. So the order of the decorator is very important here. By this order, first we return 10 from this get number. We multiply it by 2, so we have 20. And then after that, 20 multiplied by 20 equals to 400. Let's run the application. Yes, we have 400. And if I change the position of these decorators, this time, first we return 10. We pass it to power decorator. It returns 100, 10 by 10. And after that, we pass it to doubler decorator. 100 multiplied by 2 is equal to 200. So you need to take care about the order of the decorator when you apply multiple decorators to a function. Well, the next thing that I want to talk about is how to pass parameter to decorator itself. Imagine that I want to change the functionality of decorator based on input parameter, or pass some messages to the decorator, or things like that. I want to parameterize my decorators. Let's see how we can do this. I'm going to comment all these codes. I don't need them. And let's send them to the top. And oops, okay. Also, let's clear it. First of all, I'm going to create two different functions. One for concatenating some string inside a list, and the other one is for summation of some integer values inside an integer list. So let's start a function, string underline join. Receive a list of input parameters. Now I have a variable name result, and return the result from this function. And I'm going to say for I in args, then result plus equal to args. I, not args. And I'm going to also duplicate it for summation. This time the result is 0, and I'm going to add a couple of numbers inside the args list and return the result. The codes are the same. So I'm going to say print string underline join and pass the list. For example, I like VRF education and channel. And also let's print another item. This is summation this time, and pass a list of items. So let's run the application. We have what it says, can only constant or not list. Oops. It's a list. I don't need to have a list here, and also for this one, sorry. So let's run the application once more. So the output is very obvious. I like VRF education channel, concat all those strings together, and this is the result of summation 1 to 5. So what if I add string here? So if I save it and run it, we have an error, unsupported operand types for int and str. So here I want to create a decorator that receive the type of data that it should work on. For example, I'm going to use something like this, type underline checker, something like this, and pass this time str, and for this one I'm going to use int. So what does it mean? It says if I'm going to say in this way that if all the items inside the args is with this type, it's okay, continue and run this function or call this function. And for this one is a string. So somehow the decorator is parameterized and help us to type checking for different type of function that acts on a list of items. So let's create, and here we pass an item, a parameter to the decorator. So we call the decorator function. We have another layer in our decorator. What does it mean? Let's also clear the output here. And so let's create the function to our decorator type checker here, def type underline checker. As the parameter, I want to receive data type with two messages. I'm going to tell you what those messages are for, message 1 and message 2. This is the decorator that I'm going to call. Here we need to return another decorator. Okay, that decorator will be able to run this inner function. So here we have def inner underline decorator, and I'm going to pass the function to this decorator. You got it? So let's pass it and oops, return inner decorator. So what does it mean? After I call this type checker, we call it this inner decorator created. This is just like before. We have a decorator that pass a function, this function, to this decorator, and we need to have a wrapper function inside this decorator that gonna responsible for calling the function and apply the business or the logic that we need to have for this decorator. So first I'm gonna inside the decorator, I'm gonna say print message 1. This message is used somehow as an indicator for the decorator. For example, here I'm gonna say you need to type check for a string, and the first method is decorator for string join, and the second one is start string, I'm sorry, string join started. And let's also correct the type checker. And here, this time you need to work on integer data type, decorator for summation, and summation start. So I have a plan or to use these two messages to tell you something very important. So here we have this print message, and inside here we were supposed to have that wrapper function or that inner function in previous examples. So here we have a wrapper function that receive also two arguments, args and kw args. And here I'm gonna return the function that we passed to our inner decorator with these two parameters, args and kw args. So when to call this function? First of all, I'm gonna print message 2 here, because this is where the real function should be started. This message start a string join or summation started, and after that we need to have a logic here. If how to check it? So I'm going to use a Pythonic way for arg in args. Let's add them inside a list, and I'm going to check the type of argument, it's equal to data type. It's a list of return values, and I'm going to use all function. If all the items or all the arg inside the args has the same data type with the data type that we sent for the type checker decorator, then it returns true. So you can call the function for this array or this list of items. Otherwise, return invalid, for example, inputs, like this. So let's run the application and give you some explanation. I forgot to oops, return wrapper function from the inner decorator. So we return the wrapper to the inner decorator, and we return the inner decorator from type checker. This is my high-level decorator that consists another decorator inside it, because I need to pass some items to the decorator. As you can see, we call the decorator function. So let's run it to see what's happened. Oops. Let's also remove this one. First, I need to show you the way that it works correctly. Decorator for string joining, decorator for summation. Message 2, what does it mean? It says what? Only concatenation, not tuple. Well, I forgot to add, I think, these to this function. So that's okay. And here, instead of message 2 as a string, real message 2. So it's okay. Let's run it. So as you can see, decorator for string join, decorator for summation. Then string join is started, and this is the concatenated string. Then summation is started, and the result of the summation. So if I add, for example, string inside this summation parameters or arguments and run the application, you can see here we have the again those two messages. The string join is started, the output summation is started, but this time we have invalid inputs because type checker here check for all the input type to be equal to integer, but it's not equal for all of the items. So this code or this line of code is not going to be run, and we're returning valid inputs. This is the way that type checker will help us as a decorator to check all the items inside the list of input parameters for this function be the same type. And also if I add an integer or a number here, let's run it. Again, you can see we have invalid inputs for both of them. So using this decorator, somehow we guarantee that these methods works on same data type. And I want to show you something with these two messages. Let's comment these two lines. If I run the application, you can see, let's run it one more time. Yeah. We have these two methods, decorator for a string join, decorator for summation, these two message 1. As I told you, we call this function. Because we call this function, we get here, we have another function here, inner decorator. We will return the inner decorator. And for inner decorator, we pass this function as a func. We print the message 1, the thing that we provided here and here. And after that, we return the wrapper. So when we call the join, the wrapper function will be called, and the message 2 and these business logics will be run after we calling the string join. So this is the way that we need to be careful how to pass the parameter to our decorators, when to run them, and how to use these parameters inside our decorator. So this is all the things that I want to tell you about decorators. I hope you enjoy the content and learn something about decorators in Python. Feel free and create some decorators for yourself and add some logics to the methods without changing the code inside the functions or the methods. just customize or modify the behavior of that function. And also, we can check for authentication here. For example, if user logged in instead of this all type, all for checking the data type, you can use some authentication mechanism to run the function. Otherwise, we can return user not authenticated. Or you can also make some caching things here, return the function. For example, function is lengthy, and you check if the input is the same as before. You're not going to run the function again. Just return the previous output that you saved somewhere here inside the inner decorator for yourself. So I hope you enjoyed the content. Let me know about your opinion about this video in the comment section. Bye bye.